Okay, in lesson 4.5, we're going to be actually graphing rational functions. We're going to be using some of the information that we learned in the previous section about asymptotes to help create these graphs. So if we look at our first function, we have x minus 1 over x squared minus 4. First thing we'd want to do is put it in complete factored form. So I'm going to write that as x plus 2 times x minus 2. And then to help you create these graphs, we're going to first make this list of information here. And so the first thing is domain. I know when I'm looking at a rational function, I just want to be careful to make sure my denominator is not 0. So I'm going to say the domain is all reals, excluding 2 and negative 2. Okay. Vertical asymptotes, I know from the previous section, right? I look at where my denominator is 0. So that would be at negative 2 and 2. So I'm going to write those, our x equals equations, remember from our Vuxhoy. Horizontal asymptotes, right? If you remember, we look at if the highest power here is lower than the highest power in the denominator, my asymptote would be y equals 0, right? So we look at power to power, and if you go back you can check that chart that we had also. The one thing we have to be really careful of in horizontal asymptotes as well as oblique asymptotes is to check to see whether at some point does it cross that asymptote. A horizontal asymptote is actually telling you what happens as you move out towards infinity and negative infinity, not so much happens in the middle of the graph. And so we have to make sure that somewhere in the middle of the graph we don't actually cross this asymptote. So if my asymptote is 0, I would just set 0 equal to that function, which is this. And I want to check to see, is there a possible solution? So if I cross multiply, right, 0 times x squared minus 4, I would get 0 equal to x minus 1. And indeed, there is a value there. The value is at 1. So I'm going to say it crosses it at 1. And then where would I go to get that y value? Well, I would plug this back into the function. So to get the y value, right, I'm going to plug 1 into, I'm going to say y would equal 1 minus 1 over 1 squared minus 4, which of course is 0. So that's why it crosses it at 1, 0, and that of course is where your asymptote is at. Oblique asymptote, we're not going to have that. Remember, my numerator would have to be a higher degree power than my denominator, so I'm just going to put not applicable. My x-intercepts are where it's sitting on the x-axis, or of course where y equals 0. Right? So what would make this function equal to 0? Well, wherever that numerator is 0, so that would be at 1, 0. A y-intercept would be where x equals 0. So if I just plug that in, let's check where that's at. Y would equal 0 minus 1 over 0 squared minus 4, and that's going to be 1/4. So there is my y-intercept. Holes, I don't have any holes this time. A hole would come if I canceled out a factor. It is no longer a vertical asymptote but a hole, and I did not do that on this problem, so we don't have any holes. So now I'm going to take all this information and I'm going to plug this into the graph. I gave you a grid here below. All right, so let's first put our asymptotes on there. If I squeeze this back up here, I had asymptotes at x equals 2 and x equals negative 2. So I'm just going to do those in a color. There's x equals 2 and x equals negative 2. Those are my verticals, and I have a horizontal at 0. There we go. So those are my asymptotes. All right. Now I'm going to include points, right? I know it crosses the horizontal asymptote at 1, 0, so I'm going to include that point on there. That's also my x-intercept, so I've already got that. And then 0, 1/4 would be right about here. And so just with those points, it's probably not enough to complete this sketch. I have to figure out kind of what's happening. So based on the fact that this is coming down, I can pretty much guess that it's going to approach that asymptote there. Now the question is does it come back down here? Probably not, or I would have had another x-asymptote, or rather x-intercept. So the fact that I don't have an x-intercept means it must come up here. So I can complete that part of the graph, but now the big question is, what happens in these chunks out here? So what happens to the right of 2 and to the left of -2? Well, I don't know. Am I in the top or in the bottom? So I'm just going to check some points. If I plug in 3, right, what would 3 minus 1 over 3 squared minus 4 turn out to be? That looks like 2/5. So if at 3 I'm at 2/5, right, and so that tells me I would have to be over in this section approaching those asymptotes. And then I need something out here, so I'm going to go to the left of -2. I'm going to try -3. So that would be, to get the y value, -3 minus 1 over 9 minus 4. And so that comes out to be -4/5. So if I plot that point, -3, -4/5, I can see that I would end up down in this corner. And then I'm using those asymptotes to fill in the rest of my graph. So you're going to gather all this information here. You're going to use that to get yourself started, and then sometimes you might need to calculate some additional points to help you fill out the graph. Let's do one more example, and then we'll continue this on in class. All right, so once again, we're going to start by just gathering this information. Let's look at this in factored form. It's x plus 3 times x minus 3 over x minus 1. Nothing cancels. My domain, I want to make sure my denominator is not 0, so all reals, x not equal to 1. My vertical asymptote is going to be here where my denominator would be 0. That's x equals 1. Now horizontal, I notice right away I have an issue, because horizontal is only when the numerator is smaller than the denominator or when the numerator and the denominator are the same power. I don't have that. My numerator is of larger power, so remember that means I actually have an oblique. So I'm going to say not applicable on that one. We know to get the oblique, I actually take the numerator, and notice I'm putting in the 0x because I'm going to do some division. I'm going to divide that by x minus 1 to figure out what my oblique asymptote would be. X times what is x squared? That's x. X times x minus 1 is x squared minus x. I'm going to change the signs and add. X times what is x? That's plus 1. I don't even really need to finish that off. So my asymptote is y equals x plus 1. Again, this is just telling you what's happening by this asymptote as we move towards kind of infinity and negative infinity. It's not telling you what happens in the middle. So again, with oblique, just like with horizontal, we have to check to make sure it doesn't cross. So I'm going to set my asymptote, my y equals x plus 1, equal to my function, which is y equals this, or I'm going to write it as the x squared minus 9 over x minus 1. So if I go to solve that, I'd cross multiply. X plus 1 times x minus 1 is x squared minus 1 equals x squared minus 9. My x squareds drop out. I get -1 equals -9, which means there is no solution. So in this case, it does not cross. Okay? So that's how we can check. So you always need to find a horizontal or an oblique, and then if you have those, you always have to check to make sure it's crossing by setting the asymptote equal to your function. All right, x-intercepts, right? We look where the function would equal 0. Well, that's where my numerator would equal 0. So that's going to be at -3, 0 and 3, 0, right? That's where y equals 0. And my my y-intercept is where x equals 0. So that's 0, comma, if I plug 0 in here, that's 0 minus 9 over 0 minus 1. To get the y value, that's going to be 9. So 0, 9. And then there are no holes on this one either because nothing canceled out. We will do an example where you have a hole, so if you've forgotten that, we'll come back to that. All right, so now let's take our information and let's put it on the graph. Let's put our asymptotes in first. So my first asymptote was vertical, and that's at 1. That's that guy right there, right? And then I have an oblique, so that's a y-intercept of 1 and a slope of 1. So that looks something like this. You can do them in color, you can do dotted lines, whatever you prefer. All right, so there are my asymptotes. Let's fill in some points I have. I have negative 3, 0. Looks to be out here. I have 3, 0, which is right here. And I have 0, 9, 2, 3. Oops, 1, 2, 3, 4, 5, 6, 7, 8. So way up here somewhere, kind of off my charts. And what else do I don't have any other holes. So I'm not crossing the asymptotes at all. So if I kind of continue this asymptote up here so we can see it a little better, right, I'm going to bend this curve so that it's approaching both of those asymptotes. So something like this. So that piece looks pretty good. I do have a point over here. I know it doesn't cross either asymptote. So I'm going to bend that in. And I don't really need any additional points on this one, right? If you're not sure, you can also always plug in another value to kind of check yourself. But since we had points on both sides, we were set. And that's it for this video.